Okay, here we go. Chapter 2, Section 1, Rational Numbers. Okay, our essential question here is, what are rational numbers and how do we order them on a number line and compare them? Okay, well, we probably should start out talking about what is a rational number, as you see right here. A rational number is a number that can be expressed as a fraction. So if we can write the number as a fraction, it's rational, like 2/3, 2 3/4, 0.45, which we would say as 45 hundredths or 45 over 100. Negative 8.25 is negative 8 and 25 hundredths. Negative 8 and 25 over 100. Okay? Anything that can be written as a fraction is a rational number. Okay? Graphing, we've done some of this already with the integers. We know that graphing in the negative fractions just be graphing on the number line to the left of 0. Okay, so if you're going to graph something like, say we had here a negative, whoops, let me get some marker here. So you want to graph negative 2 and 3/4. Okay, well on the number line, okay, here would be 0. We're going to the left, there's negative 1, there's negative 2, and let's carry this out here a little bit more. And here's negative 3. You think negative 1, negative 2, and then 3/4 of the way would put you right there. That would be negative 2 and 3/4. Okay? It's 3/4 of the way closer to negative 3 because that would make it bigger there. And that's how you get the you graph in the negatives with the fractions. Okay? If we wanted to graph 1 and 1/2, there's 1, there's 2. 1 and 1/2, 1 and 1/2. Boom. Just like that. Okay? Very similar to what we did with the integers. Just pay attention to your fractional parts. Okay? Come on, move. Sorry about that. Whoops. Technical difficulties here. We'll work all that out. Okay. All right. So what is a terminating or a repeating decimal? Okay. We think about terminating and repeating decimals. When changing a fraction to a decimal, you divide the top number of the numerator by the bottom number denominator. We've been talking about this. How do you change a fraction to a decimal? Like your test scores or your quiz scores, you're always asking, what is that as a percent? Okay. Top divided by the bottom. All right. Now, when you do that, if it's a terminating decimal, if the decimal digits, when you divide, they don't repeat, they end. Like 1/2, 1 over 2, 1 divided by 2 is 0.5. Okay, that terminates, it stops. There's nothing else you can do. But if you get something like 1/3, okay, then you end up with uh, something like this. Like here's 2 and 1/3. You get 0.33333. That's representing your 1/3. That just keeps on going on and on and on and on. It never stops. Okay, 3 divided by 8. So this would be a repeating decimal. 3/8 or 3 divided by 8, top divided by the bottom, is 0.375, and you get no remainder. So it terminates. Negative 3/4 would be negative 3 divided by 4, negative 0.75, negative 75 hundredths. Okay, it terminates, no remainder. 6 and 1/8, 6 plus the 1 divided by 8, the 1/8 is 0.125, it terminates. Okay, there's no remainder. But the 1/3 keeps giving you that remainder. You always keep getting a 1 left over, divide, bring down to 0, you get 10, you put 3 in the 10 3 times, and you get 9, you get a remainder of 1. It just keeps on going. You've worked with 1/3 before. A lot of times we would show this by putting a line over the 3. Okay? You have that 3 right there, and you just, if I can get it there, boom, you just put a line over like that. And whatever's underneath the line, that's telling you that that's repeating. Okay? It could be two numbers. When you start looking at the 1/9, the 2/9, they'll repeat like 111 or 222, or sometimes you get 2727, whatever it might be. They'll repeat. Okay? All right. How do you compare rational numbers? Well, if you can graph them on the number line, you can compare them pretty easy then, okay? Whichever number's to the right on the number line, that's the bigger number, okay? But we don't always draw a number line for them. So what are some other ways we can do it? If they have the same common denominator, it means the number on the bottom is the same. Then compare the top number, the numerator, okay? And remember, when you're dealing with negatives, think oppositely, okay, with the negative. Because the bigger the negative number, the smaller value it has. Because negative 10 is way over here compared to negative 2. Okay, it's further to the left. So negative 10 is actually smaller than negative 2 because of the negative. Here, if you want to compare negative 2 and 3/5, it's going to be greater than negative 2 and 4/5 because that 4/5 is going to be more to the left, okay, than the 3/5 when you look at them in negatives, okay? So their absolute value, the smaller one, is going to be the bigger of the negatives, okay? When the denominators are different, try to find a common denominator, okay, and then compare them like above. You can also cross multiply the two fractions and see which is the bigger side. We'll talk about that some more in class. But to compare here, if you had 7/12 and 8/18, okay, change, when you look at the 12 and the 18, you realize, hey, they both go into 36, okay? And there's other numbers they go into, but I chose 36. So to get 12 to 36, I got to multiply the bottom by 3. So I multiply the top by 3, or 3 over 3, okay? And that gives me 21 over 36. 18 goes into 36 twice. So I multiply the top and the bottom by 2, 2 over 2. So that gives me 16 over 36. And then since 21 is bigger than 16, this is the bigger number. If they were negatives, it'd be the other way. One other thing about your greater than and less than symbols, remember, we always eat the bigger number. The alligator eats up the bigger number, okay? If I remember that from elementary. When you're comparing the decimals, just go by place value, okay? If you're going to compare 2.729 or 2 and 729 thousandths with 2 and 7,234 ten thousandths, okay? You start with the biggest place values and work your way to the right. So they both have a 2, so they're the same. They both have a 7, so they're the same. This one has a 2 in the hundredths place. This one has a 2 in the hundredths place. This one has a 9 in the thousandths place. This one has a 3 in the thousandths place. So this one's bigger, okay? And I've got my symbol going the wrong way, okay? That should go the other way. It should be eating this one up, okay? Oh, wait a second. Did I write them down backwards? I didn't write it down correctly. That's why. That should be a 2 right there. How about that? 729, 724, okay? So this one, I just actually rounded it up. So that's why, but you can see, get this right, 3, 4, put the 2 in there. Okay, now that's right. Okay, so you can see right here, the sign's still back. This is still bigger than this is, okay? This sign is backwards. I'm not going to fix it right now. You fix it. It should eat up this way because the 9's bigger than the 3. All right? So we're going to look at more examples of that in class, but just to remember, rational numbers, numbers that can be written as fractions. We've dealt with them on the number line. Changing a fraction to a decimal, just divide the top by the bottom, okay? If something repeats, you can put a bar over it. That's like 1/3. It's non-terminating. It keeps on going forever. You compare them, try to get a common denominator. And decimal place values, remember my inequality symbol is backwards. It should be the other way. Okay? All right. We're going to look at that in class. Go over a bunch of examples there. And we'll look at some application of it then. All right. We'll see you then. Have a good one. Bye.